Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In this session, in continuation with the previous session, we are going to study about the measure of association and the sampling distribution. We are going to step into a new topic called sampling distribution. For that, some basics are required. The objective of this session is to work out a sum regarding the association of attributes. Next, basics of sampling distribution are dealt with by discussing some definitions. So, 3 examples have been worked out in finding the coefficient of association in the previous sessions. So, in continuation with that, we will work out one more problem in finding the association between the 2 attributes. The example 3, which was worked out in previous session, deals with preparing a 2 cross 2 contingency table regarding the attributes given. Here the table is given and you have to extract the information from the table and then work out the coefficient of association, and then we will find out the exact association between the attributes concerned here. Okay. So, what is the attributes given? The following table gives the distribution of students and also of regular players among them according to age in completed years. Age in years is given as 15, 16, 17, 18, 19, 20, and number of students who are in the age of 15 is 250, and who are in the age of 16 are 200, and similarly 150, 120, 180. And one more information is given in the question about the regular players. The regular players among the 250 students in the age group of 15 is 200, and 150 students are regular players in the age group of 16, like that. What is the question? Find the coefficient of association between majority and playing habit. So, you have to define the attribute A as the number of students who are major. Who are major means above 18 and above years of age, and playing habit regular players or non-regular players, on the assumption that majority is attained in 18th year. So, we will work out this problem. Let A is equal to majority, that is greater than or equal to 18 years of age. B represent the regular players. When A represents majority, then alpha represents a minority, right, less than 18 years of age, and then beta represents non-regular players. Okay. So, what is the information given in the question? That is number of from the given data we have number of major students. Number of major students is 18 and above aged people, that is 120 plus 100 plus 80. So, this is given as A is equal to 120 plus 100 plus 80, which is equal to 300. So, therefore, number of minus students will be alpha which is equal to 250 plus 200 plus 150, which is equal to 600. Similarly, number of major regular players This information also you have to get it from the question. Number of major regular players, they are denoted as AB is equal to 48 plus 30 plus 12, which is equal to 90. Similarly, number of minor regular players is equal to alpha b, which is they are equal to 200 plus 150 plus 90, which is equal to 440. Okay. From this information we will get another class frequency of order 2 from this. So, A beta is equal to A minus AB, which is equal to 300 minus 90, which is 210. Similarly, alpha beta, because the 4 class frequencies of order 2 are required for finding the coefficient of association Q. Okay, that is AB, alpha B, A beta and alpha beta, right. So, alpha beta is nothing but alpha minus alpha B. Okay. Alpha value is 600 minus 440, which is equal to 160. Now, we will find out the coefficient of association, Yule's coefficient of association Q. Q is equal to AB into alpha beta minus A beta into alpha B, divided by the same thing in the denominator with plus A B into alpha beta plus A beta into alpha B. Now, substitute all the values you have calculated from the given data, that is 90 into 160 minus 210 into 440 divided by 90 into 160, the same thing in the denominator plus, but with a plus sign, and this value gives you minus 0.73, which is less than 0. It means the two attributes are negatively associated, that is the number of students who are major or minor is not at all associated with the players are regular or not regular. So, this is what the information we have arrived from the given data. Now, so far we have discussed the measure of association called coefficient of association. We have worked out an example in finding the association between the two attributes. Next, we will step into a new topic called sampling distribution. We have discussed some distributions in the statistical methods 1, that is binomial distribution, Poisson distribution, normal distribution, and then geometric distribution, negative binomial distribution. All those distributions are either discrete or continuous. It is based on the values of the random variable it takes. Okay. So, in continuance with that, we have a new distribution called a sampling distribution, which is based on the sample taken from a population. So, before going into the deep study of sampling distribution, some basic notions are required. What are the notions required? Before giving the notion of sampling, we will first define population. So far, who have not studied statistics, population means people, but in statistics, population means whatever the information you are taking into consideration will be called as population. So, in a statistical investigation, the interest usually lies in the assessment of general magnitude and the study of variation with respect to one or more characteristics relating to individuals belonging to a group. Okay. We will be testing the individuals with respect to their general magnitude and then their variation with respect to some characteristics. Okay. So, first of all we will define what is population. This group of individuals under study is called population or universe. Thus, in statistics, population is an aggregate of objects, animated or inanimated, under study. The population may be finite, countable or infinite. It is obvious that for any statistical investigation, complete enumeration of the population is rather impracticable. This particular paragraph is given about why we are doing the sampling. The sampling is nothing but taking a sample is called sampling. So, what is meant by sample? First of all, a part of the individuals is called a sample. A part of the objects you are going to take into study for consideration will be called as a sample. Okay. So, a part of it will be called as sample, and taking a sample, the process of taking a sample is called sampling. Then why do we study sampling? That is what is given. It is statistical investigation for complete enumeration is not practiced, is not possible sometimes. For example, if we want to have an idea of the average per capita monthly income of the people in whole India, then think about the population in India. We will have to enumerate all the earning individuals in the country first of all, which is rather a very difficult task. And even if the population is infinite, complete enumeration is not possible. Also, in some cases where you are talking about the crackers, explosive materials, 100% inspection though possible is not at all desirable. But even if the population is finite or the inspection is not destructive, 100% inspection is not taken into recourse because of multiplicity of causes. What is that? First of all, administrative problem, then financial implications, time factor. We keep on going investigating innumerable population is time consuming and it is waste of time, okay, and etc. So, we take the help of sampling. This is why we do the sampling procedure. Okay. As I already told you, population is the whole of the universe of the or the objects taken into consideration for statistical study will be called as population, and sample will be a finite subset of statistical individuals in a population is called a sample, and the number of individuals in that particular sample will be called as a sample size. When we talk about theory and in statistical treatment is required, all the theory has to be converted to mathematics. For conversion into mathematics, we need some measures, as we have discussed in the attributes. So, when we talk about the measures, we have to talk about their notations, right. So, the notations with respect to the population will be called as parameters, and the notations with respect to the sample will be called as statistics. So, parameters means statistical constants of the population, viz. Mean mu and variance sigma square etc., which are usually referred to as parameters. Parameters are the constants with respect to the population. Statistics are the statistical measures computed from the sample observation alone, example mean x bar and variance s square. Just look at the notations. Mu also stands for mean and x bar also stands for mean, but mu stands for the population mu and x bar stands for the sample mean x bar, and similarly the variance sigma square is for the population and variance s square will be for the sample. Okay. So, what is the basic fundamental problem of sampling theory? The determination or the characteristics of the variation in the values of the statistic obtained from different samples that may be attributed to chance or fluctuations of sampling is one of the fundamental problem of sampling theory. This is why we do the sampling. Then when you talk about a procedure, definitely we have to talk about its distribution, because statistics deals with various distributions. Distribution means a particular format where the variable follows. Okay. We have discussed with discrete distributions called binomial, Poisson and geometric negative binomial, etc., and with some continuous distributions called uniform distribution, normal distribution, and etc. So, with that type, a sampling distribution of a statistic, if we draw a sample of size n from a given finite population of size capital N, the total number of possible samples is NCN. NCN is n factorial by small n factorial into capital N minus n factorial. We call this as K. For each of these K samples, we can compute some statistics. T is equal to T of x1, x2, etc. up to xn. In particular, the mean x bar and the variance S square as given below. First of all, take a sample number, then take the statistic. The statistic is generally denoted as T, and its measures are x bar and S square. So, when the sample number is 1, the statistic will be called a T1 and the corresponding mean is x1 bar and corresponding sample variance will be S1 square. Similarly, for the sample number 2, you have T2, x2 bar, etc. will be then S2 square. Likewise, there are going to be K samples, right. So, the statistic will be Tk, then xk bar, etc. Sk square. Now, this is the table of a sampling distribution. The set of values of the statistics so obtained, one for each sample, constitutes what is called sampling distribution of the statistic. For example, the values T1, T2, etc. up to Tk determine the sampling distribution of the statistics T. In other words, statistic T regarded as a random variable which can take the values T1, T2, T3, etc. up to Tk determine the sampling distribution of the statistic. And we can compute various statistical constants like mean, variance, skewness, kurtosis, etc. for its distribution. Just recall, in binomial distribution, the random variable x will be taking the values from 0, 1, 2, 3, etc. up to n. When we discussed binomial distribution, we discussed the binomial distribution is about x successes out of n trials, where x will be taking the values from 0 to n, 0, 1, 2, 3, etc. up to n, it is countable. And similarly, like x taking the value 0, 1, 2, 3, etc. up to n in binomial distribution, in sampling distribution, the statistic T regarded as a random variable will take the values T1, T2, T3, etc. up to Tk, and this particular random variable defines a distribution. That distribution is called a sampling distribution of the statistic. In just again recall about binomial distribution. In binomial distribution, we have computed mean, variance, moment generating function, moments, etc. And the mean of binomial distribution is NP, variance of binomial distribution is NPQ, and the moment generating function of binomial distribution is Q plus P e power t whole power n, and the moments we have calculated mu1 is 0, mu2 is NPQ, that is variance, mu3 like that we have computed the moments, and using the moments skewness, measure of skewness and kurtosis was also developed. Okay. Like we have done in the binomial distribution, we can also compute the statistical constants mean, variance, skewness, kurtosis, etc. for this sampling distribution of the statistic also. For example, the mean and variance of the sampling distribution T are given by T bar is equal to, how many samples are there? It is K samples. So, T1 plus T2 plus etc. plus Tk, right. And then variance of T is equal to 1 by K T1 minus T bar whole square plus T2 minus T bar whole square plus etc. plus Tk minus T bar whole square. Okay, this gives you variance of T. So, these are the two basic measurements which a random variable you can calculate with. After discussing about a sampling distribution, parameter and statistics, next we step into defining the standard error. The standard deviation of the sampling distribution of statistics is known as standard error and it is abbreviated as SE. Why do we study standard error? The standard errors of some of the well known statistics for large samples are given below, where n is the sample size, the population variance being sigma square and p the population proportion and q is equal to 1 minus p. N1 and N2 represent the size of two independent random samples respectively drawn from the given population. This tabular column describes you about the statistic and the corresponding standard error. Okay. The first one is sample mean. If the statistic is sample mean x bar, then the corresponding standard error is sigma by root n. All these statistics are accounted for testing, therefore, the corresponding standard errors has to be studied. Each statistic will be normalized using the normal distribution Z. Z is equal to T minus a statistic T minus expectation of T divided by standard error of T. So, all the standard errors which you are seeing in the tabular column will appear in the denominator of the standardization of a particular statistic. Okay. So, if the statistic is sample mean x bar, then the corresponding standard error is sigma by root n. Everything has its usual notation. Sigma stands for population standard deviation and n stands for sample size. Next, the observed sample proportion p. The corresponding standard error is root of pq by n, where q is equal to 1 minus p. Next, sample standard deviation is the statistic, then corresponding standard error is root of sigma square by 2n. Sample variance S square, the corresponding standard error is sigma square into root of 2 by n. Next, the sample quartiles. Quartiles is 1 point. All these are just the formula, no kind of derivation is required. 1.36263 into sigma divided by root of n. If the statistic is sample median, then the corresponding standard error is 1.25331, 3 sigma divided by root n. If the statistic is sample correlation coefficient R, then standard error is 1 minus rho square divided by root of n, where rho stands for population correlation coefficient. If the statistic is sample moment mu 3, sample moment mu 2 is nothing but sample variance, we have seen S square. So, sample moment we will talk from mu 3. Mu 3, the standard error is sigma cube root of 96 divided by n. And if the statistic is sample moment mu 4, then standard error is sigma power 4 into root of 96 divided by n. Sample coefficient of variation nu is equal to standard error nu divided by root of n into root of 1 plus 2 nu cube by 10 power 4, which is approximately equal to nu divided by root of 2n. Then, if the statistic is difference of two sample means x1 bar minus x2 bar, then the corresponding standard error is sigma 1 square by n1 plus sigma 2 square by n2. This particular statistic and standard error will have an importance in doing these sums in testing of significance. Okay. Similarly, difference of two sample standard deviation is a statistic means S1 minus S2, then the standard error is root of sigma 1 square by 2 n1 plus sigma 2 square by 2 n2. Next, difference of two sample proportions is P1 minus P2, which is equal to root of P1 Q1 by n1 plus P2 Q2 by n2. Now, what is the use of studying standard error? Standard error plays a very important role in the large sampling theory, where we have discussed a sampling theory. Large sampling theory means if the sample size is greater than 30, it will be called as large sample, and if the sample size is less than or equal to 30, then the sample will be called as a small sample. So, it plays a very important role in the large sample theory and forms the basis of testing of hypotheses. As I already told you, all the statistic will be converted to the standard normal distribution Z, and for that normalization, standard error plays a very important role by giving its structure in the denominator. If t is any statistic, then for any large samples, Z is equal to t minus E of t divided by root of variance of t, and this follows a standard normal distribution 0, 1. Root of variance of t is nothing but standard deviation of the statistic, and the standard deviation of the statistic is what is called a standard error, and it is shortly written as SE of t. Okay, this is for large samples. Thus, if the discrepancy between the observed and hypothetical expected value of statistic is greater than Z alpha times its SE, then null hypothesis is rejected at alpha level of significance. Similarly, if the deviation is not regarded significant at 5% level of significance, then we have to go ahead with the standard normal distribution. So, in other words, the deviation t minus E of t could have risen due to fluctuations of the sampling, and the data do not provide us any evidence against the null hypothesis. Now, these terminologies, hypothesis, test of significance, level of significance, terminologies we will be studying in the later sessions, hence which may therefore be accepted at alpha level of significance. Okay. After discussing the measure of association of attributes, after working out an example in measure of association of attributes, we stepped into discussing about a new topic called sampling distribution. Why sample, why population is not taken into account for the investigation, why do we do the sampling, and some basic terminologies like population, sample, parameter, statistics, standard error, and etc. was discussed. Also, sampling distribution tabular column for various statistics have been given in this session. Based on the discussions in this session, the following questions may be posed. What is meant by sampling distribution? Define population, sample, parameter, statistics, and standard error. Give the standard error for various statistics like sample mean, sample moment, etc. Various statistics means sample mean, sample standard deviation, sample variance, whatever the statistics which you have studied in this session, we can give the standard error. So, give the standard error for various statistics is one of the question. Thank you.